Alright, so on this video what we want to do is we want to be able to meet two of the objectives for this chapter. We'd like to be able to compute measures of relative standing for individual values in a distribution. This includes standardized values z-scores, which we're going to look at here in a little bit, and percentile rankings. And then we also want to be able to use Chebyshev's inequality to describe the percentage of values in a distribution within an interval centered at the mean. So these are the two objectives in this video that I'd like to be able to hit. And let's go ahead and get started on that. If you want to have your notes out and ready to go, we'll start taking a look at that. Alright, during this lesson there'll be three vocabulary words that we need to make sure that we're familiar with: z-score, percentile, and standardizing. So make sure by the time we're done with this video you are able to work with those three vocabulary terms. Alright, you might want to take a minute or two just to pause the video and read the intro to the data sets that I have below regarding the degree of reading power test. At that time, if you want to start it up again, and I'll talk a little bit about these data sets. Alright, so we have these data sets for the degree of reading power test in Miss Apple's class and Mr. B's class, and what we want to do is we want to be able to look at the location of a score of 40, whether it's in Miss Apple's class or Mr. B's class, and compare that location to the entire distribution. So to do that, what we want to do is we want to examine all the information about that particular these particular data sets. So to begin with, let's take a look at the stem and leaf plot. Okay, and you'll notice the stem and leaf plot, you can get a pretty good idea of kind of the shape of that graph, and for both of them. And then also we have our 5-number summary for both of them. So we have Miss Apple and Mr. B, and really that tells us a lot about the actual distribution, but it doesn't tell us anything really about the relative score of 40 related to the rest of the data set. We can make some assumptions by kind of looking at where it is within the distribution. But what we want to do today is we want to have a way where we can go through and actually have a standardized way of describing how that score relates to the rest of the distribution. So to describe the location of that individual test score of 40 within our distribution, what we want to do is we want to use something called z-scores. And what we can do is z-scores, we can give a z-score to every single individual test. And really what a z-score is it tells us how many standard deviations away from the mean the original observation falls. Okay, so if x is an observation from a distribution that has known mean and standard deviation, the standardized value, and that's key, standardized value, that's our term there, of x is this equation right here. In other words, the difference between the value and the mean divided by the standard deviation. So really all it does is it tells us how many standard deviations from the mean it is. Okay, so we say that a z-score is a standardized value, and generally we will refer to the original values as raw scores. Okay, so they can tell us where an observation falls standing relative to a distribution, the direction in which the observation falls, either positive or negative, and converting scores from their original values to standard deviation units is called standardizing. So anytime we take a value and put it into a z-score, we're standardizing that score. Okay, an observation that is equal to the mean would be 0 when we look at a z-score for that particular value. Alright, the second term that's important in this particular section is percentiles. And percentiles is a term that we've already kind of looked at before, but basically it's the pth percentile of a distribution is the value such that p% of the observations fall at or below it. So if you're at the 88th percentile, that means 88% of all people who took a particular test would be at your score or below your score. Now, in some cases, you'll see percentile defined not as at or below, but just below it. So just be aware of that, and as you're looking at different definitions of percentile. The final term or theorem that we need to take a look at is Chebyshev's inequality, and it says that in any distribution the percent of observations falling within k standard deviations of the mean is at least 100 times the quantity 1 minus 1 over k squared. So if you think about Chebyshev's inequality, it gives us some insight into how observations are distributed within the distribution. It does not help determine the percentile corresponding to a given z-score. So it's not going to give us a percentile, it's just telling us how many are going to be within that many deviations of the mean. So for instance, if we have k is 1, or in other words within 1 standard deviation, it doesn't tell us a whole lot. It says at least 0% of observations fall within 1 standard deviation. Now the key is at least. So there could be more. In a lot of cases there will be more, but for 1 standard deviation it doesn't tell us a whole lot. However, when we go to 2 standard deviations, at least 75% of observations fall within the mean in that particular situation. So now, as soon as we go to 2 standard deviations, at least 75% will fall between those 2 standard deviations of the mean. It goes up to 89, then 93.75, and finally at 5, 100% of all observations will fall within 5 standard deviations of the mean, according to Chebyshev's inequality. All right, let's take a look at example number 1 then. It says, referring to the DRP scores, compare the z-scores of a student who scored a 40 in Miss Apples and Mr. B's class. Okay, so let's go back and look at the DRP scores and kind of look at the information that we have. So if we're looking at a 40, so we're looking at that student that we had highlighted here, this 40, we want to find a z-score related to that particular student. Well, to do that, I'm going to need to know what the mean was, and I'm going to need to know what the standard deviation is. So those two pieces of information will help me determine the z-score, because remember, a z-score is really telling us how many standard deviations away from the mean that particular score would be. So if we're going to do that, coming down here, if I go ahead and look at that for in Mrs. Apple's class, I'm putting in, really I'm finding the difference between the score 40 and the mean and dividing it by the standard deviation. So if I do that, 40 minus 32.6 divided by 11.6 is 0.64. So in Miss Apple's class, a score of a 40 is actually 0.64 standard deviations above the mean because it's positive. Okay. However, in Mr. B's class, that would represent 0.24, or just a little bit less above the mean in his particular class, because we know in Mr. B's class the mean was a little bit higher. Therefore, that score of 40 is closer to the mean. All right, example 2S is to determine the percentile score of a student who scores a 52 on his or her DRP in Mrs. Apple's class. Well, in her class there were 22 scores, and 21 of them were at 52 or below. So if we look at our data set here, you can see here's the 52 in Miss Apple's class. 21 of them are at or below that particular score. Therefore, to find the actual percentile, I'm going to take that 21 and divide it by the total number of 22, which is 0.95. Therefore, that student would be at the 95th percentile. All right, the final example says determine a percentile score of a student who scored a 15 on his or her DRP in Mr. B's class. Well, a 15 was the lowest score, therefore it's going to be the first out of 22 scores, which would be 0.05 or the 5th percentile. So that would be the score, that would be the percentile for the lowest score in his class.